Okay, we're going to start with congruent segments. Congruent segments, well, we remember segments are just part of a line. And this congruent, what you guys will think of is it's kind of like equal to, but it's a little bit different. And so we get congruent segments are segments that are the same length. Now, congruent is kind of like equal to, and that's how you guys are going to think of it a lot of times, but it's a bit different because it only talks about shapes. So shapes and figures. So that's why we have that. It's got its own special little sign up here. It's like an equal to with this little squiggle over top of it. And segments, same length. It's similar to equal to, but different in the fact that it only talks about shapes. Equal to talks about numbers. And we've also got these other couple of terms here, postulates and theorems. Postulates are new. These are just statements that we accept. They're accepted as true. These are rules of geometry or other math classes as well. They're just statements accepted as true. They're the rules. And from these rules, we get theorems. And theorems are statements that are proven true. One of them that you would know right away would be the Pythagorean theorem, that a squared plus b squared equals c squared. That's one of the big theorems out there that you guys probably have heard of. But these come from postulates. So we have the postulates, the rules, and then everything that happens because of the rules, those are theorems, and we can prove those are true. And then we use these to talk about a couple of things here. We're going to start with this ruler postulate. And the ruler postulate points on a number line matched 1 to 1 corresponds to the point is according to that point. So we've got a number line, 0 in the middle, and it goes 1, 2, 3, -1, -2, -3. And we can come over here and we get to some point. I'm going to call that one B. And we can come over this way and get some point A. And really where this comes into play is if I want to find the length, what I do is I just take the bigger one, B, minus the smaller one, A. So B minus A, that's length. And that's what the ruler postulate really helps us with. And in this example, K is between J and M, L is between K and M is between K and N. I got J is 14, K is 4. These three are equal, and I want to find this stuff right here. So before I do anything here, I want to start by drawing a picture. K is between J and M. That means the ends are J, M. K is somewhere here in the middle. So that takes care of this statement. Then it says L is between K and M. Well, here's K and M. L is somewhere in the middle, L. That takes care of this one. Then M is between K and N. Well, here's M. Here's K. M has to be between K and N. That means N has to be over here somewhere. So I'm just going to make that a little bit longer and make that point N to take care of this one. Now, if I start labeling stuff, JN, the whole thing here is 14. KM is 4. Then I got all this stuff here. Now, JK is equal to KL is equal to KM. Well, KL equal to LM equal to JK. Well, that means this one's equal to, and I didn't draw my picture right. And that's going to happen quite a bit. We're not going to know exactly what it should look like. So we're going to mess up drawing these pictures. It's okay. I'm not going to redraw it. I'm just going to leave it like this and know that, oh, yeah, it doesn't look like it, but it really is the same as these two. And I just say not drawn to scale. It's kind of the cheater way to get around not having to redraw it, but it saves us a lot of time. Now, Km is 4, and we just said these two parts are equal. That means these two parts are both going to be 2. So I'm going to put 2's right in there. Nice thing is JK also has to be 2 because it says it's equal to those other two. So just because I drew it wrong doesn't mean that it's not the same. Now I'm going to find this last part that I don't have labeled. I know the whole thing's 14. I know this is 2, this is 2, this is 2. To get this part, I just take 14 minus 2 minus this 2 minus that 2, which is 14 minus 6, which makes this part here 8. Now, once I have those all labeled, it's really easy to answer these questions. I just want to find JK. JK, oh, I've got that labeled. That's 2. I want to find KN. Oh, well, KN is from here to here. I just add up these parts, 2 and 2 and 8. That's 12. MJ, I add up all the pieces from M to J, 2 and 2 and 2. 6. And L. Go from N, go to L, to 8 and 2. That's 10. It's way easier to make sure all these bits are labeled first and then just add up the pieces as we go along. And that's the ruler postulate. Now the segment addition postulate, this rule, it's right down here. B is between A and C, AB plus BC equals AC. What this is going with is I've got this segment, A and C, B is in the middle. And if I take this part plus this part, it equals the whole thing. And that's the big part of this. The segment addition postulate is part plus part equals the whole. And that's going to come up a lot. Make sure you know that. Part plus part equals the whole. I'll ask you about that in class all the time. And if I have that, then I can do this question up here. M is between L and N, gives me some bits here, and then I want to solve for Y and find these. So I start by drawing my picture. L, N, M is in the middle. Then I'm going to label it LM, 7Y plus 9. MN, 3Y plus 4. LN, the whole thing, is 143. And then this looks a lot like this picture down here. This picture here, a lot like this picture right here. So I know it's going to be a part plus a part equals the whole thing. And so I look over here and I say, oh, what's one of my parts? Well, it's the 7y plus 9. What's another one of my parts? 3y plus 4. What's the whole thing? 143. And then this is this nice algebra equation, which we talked about and reviewed, and that was the whole reason we spent all that time reviewing, is to make sure you guys could solve this. Collect my like terms. 7y and 3y is 10y. 9 and 4 is 13. Subtract 13 from both sides. Divide both sides by 10. Y equals 13. And that's great. Now be careful here. I found y, but don't just put a box around it and call it good, and then just go on to the next problem, because then I'd count things wrong and you'll get things marked off and it's no good. Because it asks us here to find the lengths of LM and MN. So to find LM, I use what it says up here. It's 7, and then it says y, but I'm going to take out the y and put in what y equals, which is 13 plus 9. And so then I work through that, and if I take 7 times 13, that's going to be 91 plus 9. That gives me 100. And I have to do the same thing for MN. 3 times 13 plus 4, that's 39, plus 4 is 43. Make sure you're answering the questions that are asked. And a nice thing is, if we check these, if we take 100 plus 43, that's 143. That is what we should get over here. So it's a really nice way to be able to check your work and see that you've done everything correctly.